and welcome to this tutorial video on the advanced configuration of AutoGaitA DLC. There's separate videos for the overall workflow and file preparation, so make sure you have checked out those. But for the advanced configuration, we click on this button and then get this window here with the first two boxes allowing you to configure the pixel threshold we use for rejecting step cycles or epochs of your behavior of interest if you have another behavior along the X and the Y dimension. So for example, the first box here says along the horizontal axis, what is the threshold for removing step cycles in pixels? So if this value is observed from one time point to the other, so if there's a change in 200 pixels from one time point to the other in your data set in this step cycle, we reject that because that can only be due to the tracking having failed. Then the same thing for the Y criterion, so for your vertical axis. You can choose to analyze accelerations in addition to velocities, which are always analyzed. You can save results, so sheet numerical results as Excel instead of CSV files. You can configure the number of bins you want to use for normalizing all step cycles to be equally long before we compute averages. You can configure the number of hind limb joints you want to plot in detail, and I'll get back to this in a bit. You can choose to use standard error instead of standard deviation for your plots. You can check this box to normalize the height of your step cycles separately, and this is recommended if you know that you have some distortions in your camera or maybe you have an uneven floor. Then it makes sense to normalize the height of all step cycles individually or separately. So the lowest point of the body across one step cycle is set to 0 and the rest is corrected accordingly. If you don't check this box, height is still normalized, but then either to a baseline file that is checked, as we have for our beam in our examples, or to the overall lowest point of the body being 0. This next box is for inverting the y-axis. So because DLC starts the coordinate numberings with the top left corner being x equals 0 and y equals 0. Body parts that are lower in the video will have a larger y value. So example, if the foot is below the nose, for example, then the foot might have a value of 15 and the nose might have a value of 10 because the foot is further away from the top left corner. And to fix that, we invert all y values. So then the nose will have a more positive value with minus 10 compared to the foot, which is then minus 15. And because we normalize heights always in these three ways I just mentioned, we have nice interpretable values after these two steps. Here with this last box, you can check whether you want to adjust x coordinates to follow the direction of movement. So this just means that we simulate that everyone was running in the same direction. So if you have some videos in which, let's say, mice were walking from left to right through the video frame, and in others you have mice that were walking from right to left, we simulate that everyone was walking from left to right. However, if you have, for example, treadmill data or things like that, then it's important to not check this box. Another important window is this one, the custom column names and features. So here you can configure the joints that you want to analyze either for the hind limb or for the forelimb, and tell us which columns or which joints belong to these two limbs, and you can configure your angles. So this is the default set that we give. However, you might say that I also want to analyze the elbow from the lower joint then being the wrist and the upper joint being the shoulder, or something like that. With these ones you can add more hind limb joints, and as I mentioned previously, you can choose the number of hind limb joints you want to plot in detail. So if you have, for example, 9 hind limb joints as I have here, then you will get the velocities and accelerations on all the features for these 9 joints in your Excel files that we output. However, if you don't want the graphics for all of these 9 joints, you can just say to plot the first 3 in detail, and then make sure that if you say plot 3 joints in detail, that we will use the first 3 that you give here. Finally, these 2 buttons are for the case that you have a beam or a baseline that you tracked that you want height to be normalized to. Then you can add, or you should configure which joints we have in, let's say, the hind limb that are not part of our main analysis, but that we also want to normalize height to. So for example, for us, we're not interested in the tail. However, it's important that, to mention the tail here as well, because otherwise in the resulting Excel files that you get, for example, these 9 joints in your main set are then normalized to your baseline, but then these 3 wouldn't be normalized, and then you would be confused why the heights don't match. So make sure to also use this button here to include all joints in this set that you're not interested in for your main analysis, but that you also want the baseline to be normalized to. And once you're done here, you click this box. You can also do the same thing that we just did for the hind limb for the forelimb to make sure that is normalized to the BM correctly as well. And then you are done.